This is 2.4, and 2.4 is about absolute value functions. In the past, in other math classes, you have done graphs of f of x equals some absolute value of some x. And you've done this algebraically, and you've also done it graphically. We're going to take this to a different level in this section, and we're going to do the absolute value of f of x. So we're going to be doing algebraically and graphically the absolute value of functions. So this video is going to be about graphing these. So graph. So traditionally in math, what you've been given is some f of x or y equals the absolute value of some x. And you have been taught that it's always going to be greater than or equal to 0. So this is the same thing with graphing these, except we're going to be given the absolute value of some function. And what we want to do is take the positive f of x, so everything that's above the x-axis, and we're going to keep it the same. So where f of x is greater than or equal to 0, it's going to stay the same. But wherever f of x is below the x-axis, we are going to make it positive. So we're going to make it be above the x-axis. So I'm going to reference back to what we did in the last section, which is doing reflections and shifts and things like that. When we said we had an x-axis reflection, we said that we would keep the x-coordinate exactly the same way it is, and we would make the y-coordinate negative. This is the same thing. It's when we took f of x and we wanted negative f of x. This is the same thing. It's an x-axis reflection. We're just using it here again. So let's use it on an example. Okay, this is actually the first example under your exercises on 2.4 from the textbook if you want to look at your textbook for this example. But they gave this graph, and this is actually the graph of y equals 2 times x minus 1 squared minus 2. You learned how to graph these equations in your last section, and it was on your assessment. But it was just the graph given in your textbook. Now it says sketch the graph of y equals the absolute value of f of x by hand and give the domain and range. So in the last part, we learned that we're going to take each x-coordinate and it's going to be the same. And the y-coordinates that are below the x-axis, we're going to make them positive because they were negative before. So this point down here at the bottom is the point 1, negative 2. Now our rule says that we are going to take the x-coordinate and it's going to stay the same, and we're going to take the negative of the y-coordinate. So we're going to be left with 1, 2. So I'm going to move that point up to 1, 2. Now the other ones are positive. We have the point 0, 0. That's going to stay the same. And we also have the point 2, 0. And that's going to stay the same. So all of this graph above the x-axis is going to stay the same on both sides. But this parabola, the bottom part, is now going to be moved to the top. And that's all. That is the graph of y equals the absolute value of 2 times x minus 1 squared minus 2. Now the domain of the function in red would have been negative infinity to infinity. And remember, these are non-inclusive brackets. But the domain of the new function is also negative infinity to infinity. Remember, domain is we're looking at the x-axis. What values could I get on the x-axis? The range of the original function was originally -2 to infinity. But the range on the new function has changed to 0 infinity. And actually, one thing that I didn't do is this -2 would be included, right? So let's make it included. And the 0 would also be included, so let's make the 0 included. Okay, let's do another example. Now this looks kind of like a cube root function, right? We don't know, we're just given a graph, so let's just do this based on just given the graph, not given any sort of function. This is the function y equals f of x. And what we want to get back is y equals the absolute value of f of x. So that means every part that's below the x-axis, we want to get that above the x-axis. So let's start with the domain of just this function first. The domain would be -infinity to infinity, and the range of this function would also be -infinity to infinity. Now let's use our rule from the last part. We're going to take every x-coordinate and keep it the same, and every y-coordinate and do the negative of it if it is below the y-axis. So on this left-hand side of the graph, for sure, that part has to come above the x-axis. So we're going to keep the x-coordinate the same, so it's going to be -2, but we're going to make that 8 instead of -8. So we're going to have the point 2, -2, 8. Now 0, 0 can stay the same, and 2, 8 can stay the same. So we're kind of left with a parabola, aren't we? And let's relabel our points. We have -2, 8, 0, 0, and 2, 8. I just took all of the pieces that had a negative y coordinate and made it positive. So the new domain is still -infinity to infinity. I'm just looking at that x-axis. What values could I get on the x-axis? And then the range is 0 to infinity, because I cannot go below that x-axis, but the point 0 is included. Okay, let's do this kind of theoretical example. If the range of f of x is -infinity to -2, what is the range of y equals the absolute value of f of x? So let's think about this. If we have -infinity to -2, so it can go up to -2, and it can be anything below that. Now, we say that if it's below the x-axis, we want to flip it over the x-axis. So all of those negative y values are just going to become the same thing, but positive. So we're going to flip this over the x-axis and just reflect it over the x-axis. So it's going to be all of this above 2 and all the way down to 2. So the range before was -infinity to -2. But now the range is above the x-axis, and it begins at 2, but it's everything above that. So now it's 2 infinity. Okay, let's end with finally graphing one of these absolute value functions. So we want to graph these each by hand. First, we're given y equals 2x plus 1, and we know how to graph this. This is just a linear equation. So remember, start with b, and then m equals 2 over 1, so the rise is 2, and we go over 1. The rise is 2, and we go over 1. And let's put some negative values on there as well, because I want to take this stuff that's on the y-axis and flip it up to the top. Sorry. Okay, so we're going to have negative 2, negative 1, negative 2, negative 1, negative 2, negative 1. So this is the point negative 1, negative 1, negative 2, negative 3, and negative 3, negative 5. Okay, so we want to flip this over the x-axis to be able to graph the absolute value of 2x plus 1. So the stuff that's on the top is going to stay exactly the same. That is this function. But these y values below the x-axis, we're going to want to make those positive. So we're going to have the point negative 1, 1. We're going to have the point negative 2, 3. I'm just making these y values positive. We're going to have the point negative 3, 5. And this is going to be our function. So do you see how we just graphed the function we already know? And everything that's below the x-axis, we're going to make those y values positive to bring them above the x-axis. Okay, I want you to pause the video and do this one on your own. Graph each equation by hand, which is y equals 3x plus 3 and y equals 3x plus 3, the absolute value of that. So go ahead and pause and then press play when you would like to see the answer. Okay, so I just graphed the function y equals 3x plus 3, and I took all of the y values that were below the x-axis and flipped them to reflect them over the x-axis. So I just made them positive, and I ended up with the points negative 2, 3 and negative 3, 6. This is the end, so go ahead and prepare yourself for tomorrow in class.